Why would you want to be able to evaluate determinants? Well, Cramer's rule is a kind of a handy-dandy reason. We're going to look at how to solve systems of 2 and 3 linear equations by using Cramer's rule. How is Cramer's rule used to solve a system of equations? Two sides of a triangle are contained in the lines whose equations are given. To find the coordinates of the vertex of a triangle between these two sides, you must solve a system of equations. However, solving this system of equations by substitution or elimination would require many calculations. Another method for solving systems equations is Cramer's rule. Gabriel Cramer was a promising mathematician. At age 18, he received his doctorate, and by 20, he was the co-chair of mathematics at the University of Geneva, when the rest of you guys are still going to be in college. Okay, Cramer's rule uses determinants to solve systems of equations. If we have ax was by equals e, and cx was dy equals f, where a, b, c, d, and f represent constants, not variables, so they're just any constant, we could take the first equation times d and the second equation times b to get the y's to drop out. So I have my y's the same now. So I have ADX minus BCX equals DE minus BF. I can now factor x out on the left side, so then I have AD minus BC equals DE minus BF, and divide both sides by that factor, and we have a way to solve for x using only the number parts of our equation. It's kind of synthetic solving for x. The same process can be used to solve for y, and so we end up with a handy-dandy solution where x equals the determinant found with the first column being the constants, the second column being the y's, over coefficients of x over coefficients of y. And the same thing for the numerator of the y's. The first column is the coefficients of x, and where you expect the y's to be, there are the constants, and then the denominator is the one we already found. Why do it twice? Coefficients of x, coefficients of y. And of course, division by 0 is a bad thing. So if we have a determinant where the denominator isn't going to end up being 0, that's going to be a no solution situation. Now, I'm going to agree with you right here. This would be easier to do with elimination. But we're going to start off Cramer's rule with something with easy numbers before we get into uglier ones that it's more practical for. So to find x, I'm going to have the constants in my first column and the coefficients of y in the second column over coefficients of x, coefficients of y. I'm going to go ahead and finish x before I do y, I think. So we're going to have negative 56 minus 32 over negative 10 minus 12. We've got negative 88 over negative 22. Negative by a negative is a positive, and I get 4. So now to find y, I want the coefficients of x, then the constants, over, okay, I refuse to do the same determinant twice. We already did it. We know it's negative 22. So now I've got 40 minus 84 over negative 22. So negative 44 over negative 22. Negative by a negative is a positive. And I get 2. So my ordered pair is 4, 2. In a vote for school colors of a new high school, blue and gold received 440 votes from the sophomores and juniors, and red and black received 210 votes from the sophomores and juniors. In the sophomore grade, blue and gold received 72% of the votes, Red and black received 28% of the votes in the junior class. Blue and gold received 64% of the votes, and red and black received 36%. Write a system of equations that represents the total number of votes cast for each set of colors in these two grades. They let T represent the total of the 10th grade and E the 11th. So the first sentence gives us 72% as the decimal point 0.72. T plus 64%, 0.64 E is 440. And 28% plus 36% is 210. Now that is not a system I would like to solve with either substitution or elimination. I can't help myself. I had to write X. Makes more sense. Okay, so I've got, for the X column, where there should be an X, we put the constants and then the coefficients of Y. And then in the denominator, it's just coefficients of X and coefficients of Y. So now what's left is just evaluating the determinants, which 2 by 2s are not too bad. The numerator, I got 24, and the denominator, I got 800ths. When I divide, I get 300. At this point, I could live with finding E or Y, whatever we're going to call it, by substituting into our equations and just solving. It seems faster to me. Divide both sides by 6400ths, and I get E is 350. I don't know, might have been about the same amount of work either way. If any of you are not too keen on the challenge presented by solving systems with 3 equations, especially if the numbers get ugly, guess what? Cramer figured out a rule for them as well. It follows the same pattern as the systems of 2 equations, where there was an X, and that column has the constants. Then we have coefficients of Y, coefficients of Z. The denominator goes coefficients of X, coefficients of Y, coefficients of Z. Same thing for Y. Where you'd think there should be a Y, we have coefficients of X, and we have constants, coefficients of Z. And for Z, coefficients of X, coefficients of Y, constants. And yes, division by 0 is undefined, so if that determinant's 0, it's all done. The main thing you need to be comfortable with using Cramer's rule to solve a system of 3 equations is the setup. So to find X, I'm going to have constants, coefficients of Y, coefficients of Z, all over coefficients of X, coefficients of Y, and coefficients of Z. And we'll go through the setup for Y and Z as well. To evaluate, according to the book, they used a calculator. So you may use Algebra to evaluate the determinants for these 3 by 3s to simplify. Okay, let's get the setup done for Y as well. So coefficients of X, constants, and coefficients of Z over the thing we already wrote. Let's get Z set up, and then we're going to use the calculator. So we have coefficients of X, coefficients of Y, and constants over the coefficients that we already wrote. Using Algebra, I have 27 over 12, which would reduce to the lovely number of 9/4. Aren't you glad you didn't do this by substitution elimination? And once I already have the denominator done, I don't need to keep doing it over and over again, so I only have 2 more 3 by 3s to do. And 3 by 3 for Y comes out as -9, which reduces to -3/4. And Z is -21/12, which reduces to -7/4. So I think you can agree there is some purpose in Cramer's rule for solving systems of three equations when those three equations are not nice to combine. I think we can summarize this video to say that Cramer's rule is a handy-dandy method using matrices and determinants to solve systems of 2 and 3 equations. The 3 equations rely on technology, but hey, we're good with that.